Good day, everyone. My name is Kagisho Kgoele from Salt Lake University. I'm still pursuing my undergrad degree in physical sciences, which I major in chemistry in it. Today, I'm going to be bringing you the presentation of light and air. In the last talk, we have learned that the distance from the sun cannot be the only factor that is we can hold accountable for the Earth's habitability. Also, we took the Earth as a bare rock with a temperature of minus 18 degrees Celsius using a model equation. We found it to be too cold for it to be habitable. In the hierarchy model, we be on the second stage, which deals with the static atmosphere and ocean. In our presentation, I'm going to bring what is air and light. What happens when light meets air by describing why the atmosphere, why the sky is blue, and also by after explaining why the sky is blue, we're dealing with will help us be able to describe what is a greenhouse effect. And also we're going to discuss why is South Africa so special with regards to light and air. What is air? Air is made up of different particles. These particles can be atoms, elements, and molecules, and also these particles come in different sizes. These particles are held constant by a fast motion, and also they are held close to the earth by the force of gravity. Our composition of air. Air is made up of 78% of nitrogen gas, 21% of oxygen gas, and 1% of water vapor, carbon dioxide, and other gases. Layers of the atmosphere. In the atmosphere, we have four layers. The first layer is troposphere, stratosphere, mesosphere, thermosphere. We are going to be using this graph to explain further. If you look at in the graph, in the x-axis, which is a horizontal line, we're going to from left to right, we see our temperature is increasing. On the y-axis, which is a vertical line, will be our altitude in meters increasing from 0 to 120 down. If you ever look, our thermosphere is the one that has the highest temperature by looking at it from with the higher altitude. Our troposphere, it is in the middle, which has many activities where we find our weather storms and other things. What is light? Many people in the past years try to explain what is light. So we're going to embark on a journey to look at our famous physicians who came up with light. In 300 BC, there came a famous physician who's called Newton, who discovered, who theorized that light is a magic being that comes from ice and can only shoot in a straight line. His theory was supposed to be true because we cannot see around a corner. 1500 years later came Isaac Newton, who discovered that a light is not a magic being because we cannot see in the dark. He also came with the theory that light comes from a white light which contain all the colored lights, and they are separated by a prism. Then years later came Thomas Young, who was able to prove Newton wrong. And also he also embarked on an experiment where he proved that light is a wave by striking a light through the slit and showing the bands after it. And in these bands, white bands and white band, you can see those bands were forming a wave. From there, Thomas Young discovered that light is an electromagnetic wave. Years later came Albert Einstein, who didn't want to argue with Thomas Young, but he came with his own theory, whereby he was able to prove that light behaves as a photon, whereby when a light strikes a metal surface, electrons are ejected from it. From those two people, light was now accepted to be both a particle and a wave from Thomas Young and Albert Einstein. So far, we have learned what is air. We have learned what is light. Now we're going to use a wave. We're going to use this wave model to, to discuss the properties of a wave. This model, it is wrong, but it's useful. You understand better when you deal with a model in a later stage. In this model, if you can see, we have radio waves, microwaves, infrared waves, visible light, ultraviolet, X-rays, gamma rays. And if you look from radio waves going to gamma rays, we can see the wavelength is decreasing. And from gamma rays to the radio waves, the wavelength is getting high. The frequency is getting high, the wavelength is decreasing. We are going to discuss furthermore on visible light as human beings can see the visible light. From the electromagnetic spectrum, that past in the electromagnetic spectrum, you can see that from radio waves to the gamma waves, our wavelength is decreasing to gamma rays, and our frequency is increasing from radio to gamma rays. And you can see that waves that has long wavelengths have low energy, and lights that have shorter wavelength have high energy. It means wavelength and energy, they are inversely proportional. Now we're going to look at what happens when light meets air. From the previous, we have learned what is air, because air is made up of particles. Those particles come in different sizes. It can be dust particles, molecules, other gases like nitrogen and water vapor, and so forth. We have also discovered that light can act both as a particle and as a wave. From this instance, we are going to deal with light as a wave when it meets air as a particle. When light meet air, many things are happening. We have reflection, we have absorption, we have scattering, we have transmitting. So, why is the sky blue? If you ever look, when the sun strikes the planet Earth, many lights are being scattered with their different wavelengths, and they are being scattered by these particles that mix up air. You do not forget that air is made up of these particles, a sort of water vapor, dust particles, other elements, and so forth, other gases. So it happens that when 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 the sun strikes these lights are scattered in different wavelengths, and blue light is the one that is being scattered mostly. As such, we can see the sky as blue. Differential scattering. Differential scattering, it happens when small particles in the atmosphere collide with lights of shorter wavelength. Lights with shorter wavelength collides get scattered the most. It is like the lights get knocked around by small particles, but the butterfly is so big it does not notice. Being a human being, us as human beings, we are more sensitive to blue light, too violent than blue light. As such, we see the sky as blue rather than violent light. Bees have in their eyes, they have different sensitivity than human beings. As such, bees see the sky as violent, human beings see the sky as blue. Why is the sunset red? During at night, the sun gets a bit closer to the earth. So it means all the particles in the air in different waveform are most scattered. Even the blue light is even mostly scattered, whereby the red light moves through and we see the red light. So during sunset we see the sky as red. The greenhouse effect. And after understanding why they say why the sky is blue and why is the red sunset red, you should be able to know that there are particles that can trap the sun, and also there are particles that can reflect the sun, and there are particles that can scatter around the sun's rays. In greenhouse effect, we're going to deal with the energy that is trapped by those particles in the air. If you look at this diagram of greenhouse effect, you can see from here is that layer of the atmosphere that traps the sun's rays and also scatter the sun's rays when light is shine upon the earth. These types of green gases, we have nitrogen gas, we have water vapor, we have carbon dioxide. Why is South Africa so special with regards to light and air? We have mountains in South Africa that enables us to study or do experiments in order to look at the difference in the atmosphere when the sun rises. Conclusion. We have learned what is air, we have learned what is light so far. We have also discussed what is the greenhouse effect. From all of this, after discovering that air is made up of particles and they come in different sizes and they are being held closer to the earth by the force of gravity, and we have learned that light has both the particles, it has both the characteristics of a particle and a wave. And in instance, we've used light as a wave. And so far, we have learned that those particles that makes up the air are the ones that traps those waves of light. And remember, air is being held constantly, which makes those sun rays from the sun being held close to the earth, which means we are going to have a static atmosphere, which makes a static atmosphere which is very hot, and it makes the earth too habitable. It makes the earth not to be habitable for us to live in. So it means we have found out that our planet earth is not that habitable for us to live in. Next up, you're going to study the circulating atmosphere and ocean to discover what else has made the earth to be habitable, since our temperature is too hot for it to be habitable. Thank you.